All right, good morning and welcome to Thursday. Today is the 29th of August, and we are just looking at the different states of matter. We've got solid, liquid, and gas, and I'm trying to find out what the fourth state of matter is. And good morning, Anna M. Good morning, Joseph. And while I'm waiting for you guys to think of maybe that fourth state of matter, I'm going to mention that I have caught up on all of the discussions. Good morning, Miranda. And so, Alexis is on the right track. So a neon light or a fluorescent light has this state of matter, this fourth state of matter inside of it. And it's the fourth state of matter. It's a little different from a gas and a liquid because it's electrically charged. Hey, Isaac, got it? It's a plasma. So a plasma is like a gas, sometimes kind of like a liquid, but it's electrically charged. Yes, Alexis, I love the teamwork. So back to your discussions. Your discussions were fantastic. But there are some little issues, and I put up an announcement that shows how to get to your comments. And so you can always do 2 attempts at an assignment. Good morning, Seth. And so you want to read over my comments, and then you can repost and fix the problems that were there, and go ahead and improve your grade. But yeah, I was very, very happy with the discussion posts. They were awesome. And just remind you to park stuff. I do want to remind you about this, that assignments and assessments should be completed independently. And I've already found 2 of the discussion posts that did some plagiarizing from a website. So please watch that. You can't have credit for anything that's plagiarized. So no copying and pasting, please, on those. You can quote and footnote if you want to do a quote. The whole thing shouldn't be a quote, but if there's one part that's quoted, that's fine. Good morning, Rukaya. Just a reminder about our Class Connect Code of Conduct that you guys are so good at being respectful and courteous. I appreciate it. So I wanted you to see some of these fabulous discussion bits. So I just pulled a couple little things from here and there. I'll give you a minute to read over these. And good morning, Jalen. Good morning, Jordan. Good morning, Nigel. I have a couple more of these to read. I see that Juliet is in here. It's weird to have 4 separate classes, so I pulled these from all 4. So very nice post there, Juliet. And Isaac's in here too. Really good post. And these were not the only good ones by any means. I only had so much space. I didn't want to like put up 15 slides of good stuff. Hello, Leilani. I just heard a private chat, and just so you know, they weren't working for me yesterday, but I'll check those in just a little bit and see if they're working today. Okay, so today we are rewinding, like I said, back to Monday when we did Half-Life, and we're going to talk a little bit more about Half-Life today. And remember that half-life is a time for an unstable atom, such as carbon-14 here, to decay. All right, so I'm going to start with this much. Back up a little bit so you can see it. This much carbon-14. All right, I've got a whole sheet of paper. You could pretend that's like 100 grams or something. Okay, and the half-life of carbon-14 is about 5,000 years. We're going to estimate to that because it's really easy for me to add and subtract. I'll just add 5,000 years. Okay, so I start with a certain amount of carbon-14, and after 5,000 years, half of it turns into nitrogen. Okay, so we've got half carbon-14, half has spontaneously decayed into nitrogen. So that's 5,000 years. Now, after another 5,000 years, another half of the carbon-14 has decayed into nitrogen. So now we have a quarter of the carbon-14, 3/4 nitrogen, and that's 10,000 years. Okay, so 15,000 years, we're left with an eighth, and my chat box isn't doing anything. Can you all type in the chat box? Are you all just being quiet, or is my chat box, okay, my chat box is fine. All right, and then after, it's 5, 10, 15, 20,000 years, we're down to an eighth. 25,000 years, 30,000 years, 35, 40,000, 45, 50,000 years. Remember, much past 50,000 years, and we can't measure the amount of carbon in a sample without and be able to accurately date it. That's because, like, almost all of the carbon has turned into nitrogen, and you're only left with that much carbon-14. Put my chair back. Oh, no, it wasn't a waste of paper. It was a teaching tool to show you how Half-Life works. I like the demonstrations. I can use it for notes later. I haven't actually thrown it away. I will definitely recycle anything that I have to or that I can. So here's another visual. After one half-life, after the second half-life, half of it continually disappears. Oh, and there's an eighth one. Good thing the paper was never alive. All right, so the graph here shows radioactive decay of a bone. Here's our bone that contains 1/8 the carbon-14 found in living animals today. Approximately how old is the bone? So go ahead and see if you can read that off the graph and figure out how old the bone is. All right, and good morning, Cameron. Let's all answer this. I would love to have an answer from everybody, so I know we're all here and participating. And good morning, Patricia. Welcome, and hello, Olivia. How are you today? And I think that's it. Good morning, Isabel. And thank you guys for reading that correctly off of the graph. We looked at 1/8 of the sample over here and followed it across and down to get the time. Now, what if they didn't have this? You can say, like, this is 100% up here. And then we've got a half is one half-life. Second half-life would be a quarter. And the third half-life is going to be an eighth. So you're just dividing by 2 on the amount every time. All right, so these are pretty simple when you have a graph to read. Let's see about this one. It's a little bit harder. And this is a bismuth crystal that is not radioactive. You might see these in a store that sells crystals, and that's actually how they form in nature. It's quite a pretty little rock. So put your answers in the chat. What do the rest of you guys think? And okay, we're going with 20 again. Let me just give you guys a little hint here. So we start off with 100, that's 0 half-lives, right? And then after 1 half-life, we're going to be cut in half, right? So that's 50 here with 1 half-life. Right. And then after its second half-life, it's cut in half again. So that's their second half-life. And the question's asking about after a third half-life. What's half of 25? And Seth and Amanda, you guys are really close. You're just rounding a little bit. Half of 25 is 12 and a half. So this one was a little bit harder. And if you had put 10 or 15, that would have been fine because you're just reading off the graph here. But I was just dividing them in my brain like it shows down here. Oh, okay. Seth, do you understand the right way to look at the graph? Okay. Okay. Guys, if you have a question or you want me to just repeat something and you don't want to put that in the chat, you can always put up a red X to tell me that you're not understanding. Or you can send me a private chat, especially if you have a red X in a private chat. I will definitely check that right away. Okay, so what if you don't have a graph to read from? So if you don't have a graph, there are a couple different ways to solve these. So you can use your fingers, which I had really poor luck with yesterday. No one really wanted to do that. You can use a table, which was what most people preferred, or we have a little equation. And I really like the table, personally. You've got 3 things to remember: the half-life, the time, and the mass. The half-life's just number 0, 1, 2, 3, 4, 5. The time just goes up by the half-life. Like when we were doing the carbon, you know, it was 5,000, 10,000, 15,000, 20,000. So that you just add the half-life going down. And then the mass, Seth, I wish we could, but you have to be able to do one of these with a table. Cameron, we don't have to use the equation. So we can just go through these with the table. But I wanted to let anyone know that does like the equations, that it does exist. And the way that the Canvas lessons did this was with the equations. Yeah, see, Rukai, I knew there'd be someone here who wanted to know about the equation. First, I'm going to go through with the table, and then I'll show you the equation. Okay, so here's an example. We have 44 grams of strontium. How much will remain after 58 years? So the first thing we need to fill in, well, this is kind of like an equation. We're just plugging in numbers. We need to fill in what we know. So far what we know is an initial mass of 44 grams. So we'll put that up in here. And it's on the next slide. I'll get to that in just a sec. What else do we have from the graph? What can we get about strontium? That might help us with this problem. Time 50. We're not going to look at the grams here. This was a different example. I just wanted you to see how it gets cut in half every single time. So this was just, I really liked how this was a pictorial representation of half-life. Like you can see there's half as much left, half as much, half as much. So what are we going to do with this 29 years? We're going to put the 29 years here in our time, because after one half-life, 29 years has gone by. After two half-lives, how much time has gone by? So 29 years for the first one, 29 years for the second one. Yeah, that's going to be 58. Ooh, 58 years is something they gave us in the problem. Okay, so that is where we wanted to be. And you could stop right there. I just showed you how you could fill in some more. So that's what we're given. Okay, we're given the 44 grams. See, Seth, the table's easy, isn't it? You already have an idea. So the next thing we have to figure out is what we're looking for. It says how much will remain after 58 years. So we're looking for our mass after 58 years. So now we can find the unknown using what we know about half-life. Every half-life, half the stuff disappears. So half of 44 is 22, and half of 22 is 11. So Seth, you got that really, really quickly. Do you want to explain how you did that so fast? And you're welcome to hop on the mic. Oh, so you just did the divide by 2? All right, guys, so give me a green check if you are good with this. Give me a green check and a red X if you are still really, really confused. I want to see that all of us are here. Yeah, Cameron, this isn't too bad. Some more green checks. Come on, guys. I need to hear from everyone that's paying attention. Thank you, Anna B. and Isaac. Thank you, Anna M. and Miranda and Rukaya and Seth. Who else is here with me? Thank you, Jacob and Joseph. Thank you, Julia. And good morning, Julia. All right. Let's try taking a look at the equation real quick. So here's our equation. So we've got our amount remaining equals our initial amount times 1/2 raised to the n power. And the n is the number of half-lives. So for this one, we had an initial mass of 44, right? So that'll go in the initial mass. When are you going to use this in life? Well, you're going to use your ability to solve problems in your life. You probably won't actually have to do a half-life problem, but your ability to look at what you're given and figure out how to solve that problem is an integral part of everyday life. Half-life, maybe if you become a certain kind of scientist, it would be useful. It's a way of thinking, in a way of critical thinking where you can analyze a situation and come up with a solution. All right, so we put in 44 for the initial amount, and we have to figure out the number of half-lives. So we had to count 29, 58, and that goes in as the power up here. Like, all right. So there's your equation. Yes, it works. It works most of the time. There's an occasional problem where it doesn't work out so well, but the table always works. All right, so let's try another one. And again, this is osmium, the picture, but it's the picture, not, it's the stable variety of osmium. Well, like Rukiah, if you have to solve for the number of half-lives, which is that N at the top, you know, I don't remember. I'm sure there's a way to do that, but I don't remember how to solve for something that is an exponent. So that is the only time when it's a problem. So what I thought we would do with this one is I'm going to put this on the whiteboard. I discovered this. Then I can make the whiteboard really big, and I can turn off my camera, and then I can give y'all tools. And I'm going to lock the eraser. And then we can kind of fill this out together. So if you want to write on the board, you can. And if you don't want to write on the board, then that's fine. It'd be a little crazy to have all of us writing on the board. What? You guys already know? All right, Alexis and Seth are going to show us how to do this. Does one of you guys want to get on the mic and talk about it? All right, so what about our time? One half-life is how many hours? No, no, not 43. One half-life. I'm going to move these because I turned your eraser off. Because I was erasing stuff left and right accidentally yesterday, so I turned the eraser off. So how much is one half-life? Two half-lives is 43. There you go, Isaac. One half-life is going to be 21 and a half hours. I moved your 43 down, Seth. I don't know, maybe my camera does work in here. So one half-life is 21 and a half hours. Two half-lives is 43 hours. Wait a second, what's half of 6? No? Y'all were right, the 12 is right at the top. Oops, moving the wrong thing. No, put the 6 back. Yeah, okay, and then what goes under 43 hours? There you go. So y'all rush just a little bit. If you want to do this with your fingers, because it sounds like you guys are kind of doing these in your head, you can count up by the time. So 21 and a half, 43, and that's my critical moment. And then I start with my 12 and I go backwards, cutting it in half. Half of 12 is 6, half of 6 is 3. So you count up with the hours and down with the amount. So that's how to do it with your fingers. All right, any more green checks? So those of you guys who are understanding these? I'll show you both solutions if you like the equation. So the next one, that's a good question. The next one would be 43 plus 21 and a half. So it'd be 64 and a half, and then 1.5. Good job, Julia. No problem, Cameron. This is practice. So it's good to try and make mistakes. Is better than not trying at all. Yeah, you start off with what's given. You start with a 12, cut it in half to 6, cut it in half to 3. No, it's science. All right, I'm not seeing any more questions on this one. So I'm going to scoot on to the next one. This one is about zinc. I wonder if I can do, I thought I could make like another page. Maybe not. This is remove all pages. Oh, I see how to make another page. Hey, I got another page. Yeah, well, I'll put this on the whiteboard too. I think I have a blank one. Yeah, here's my blank one. Kind of blank. All right, so I'm gonna turn off my camera so we can see the whole thing. This one is a little different. So I did a little assistance here by telling your unknown now is what did we start with? Okay, so how, and don't fill that one in yet, okay? First, we have to get up to our 7.2 minutes. Okay, so that's when we have 12.5. I can put that around here. So we have to get up to this point where we have 7.2 minutes, and then we can put the 12.5 grams to the right. So what's gonna go right below 2.4 minutes in this next box? Right, we've got 4.8 minutes. And then we have to get up to 7.2. So what goes in the next box here? Guys, you can help them out in the chat there. What are we gonna do to get the next half-life time? Rukaya, you're already at the end. Yep, we're gonna do 4.8 plus 2.4. Rukaya went with the equation. And it worked. All right, so 4.8 plus 2.4 is 7.2. Where do my dots keep going? My dots keep erasing. Anyway, once we have our 7.2, then what goes with it over in the mass column? Yes, Seth, as you go down the time, you keep adding the 2.4. So the next one would be, if you wanted to do it, 9.6. Oh, sorry, I'm really bad at writing with the mouse. All right, so we've got 12.5 goes with the 7.2. That's what was given in the problem over here on the left. And so as we go back up a level, remember when we went down the levels, we cut everything in half, right? So as we go back up the levels, we're actually going to be doubling it. So the 12.5 doubled is 25. What's 25 doubled? 50. And I see to get to the top, we're gonna double 50. So what's 50 doubled? It's 100. So if I wanted to do this with my fingers, let's start with the 2.4 minutes, 4.8 minutes, 7.2 minutes, and then that's the 12 and a half. Now I would double it to 25, double it to 50, double it to 100. So I like using my fingers. Anyone else like the finger method? Oh, yeah. 71 is part of the name. Okay. Yeah. There's always that extra number in there to throw you off on these. So make sure you don't use the isotope mass in the problem. Good point. I like that you pointed that out, Seth. All right, and Alexis, you're good with the finger method. That is fabulous. All right. So there we go. So, if you guys want to look through the PowerPoint, or if you ever want to download the PowerPoint, do you all know how to do that yet? Okay. So on the whiteboard, it's the little corner thing, there's like 3 little lines right there on the corner of the whiteboard. If you click on that, that'll give you my attachments where you can download things, and my presentations, you can pull the presentation on the whiteboard and you can go through the slides. And so I made it this time where in the breakout room, you can do that. So this brings me to our check here. So some of you guys are probably really good at this, feel comfortable with it. And so you might want to go take a 5-question quiz where you can check your answers at the end and do some practice on your own. Or you might want to do this quizzes that goes through Half-Life and does some practice as well. So if you're ready to practice on your own, I can put you in the quiet breakout room. If not, I have more of these to practice here on the board. So this is where I'm kind of differentiating it for you. So if you want to go to the breakout room and try these links, just give me that green check. The links are not working on the PowerPoint. I don't know why this time they didn't work, but I put them in the chat. An extra kitty. Okay. So yes, I will put you in the quiet zone. If they're not in the chat, let me know. If you can't get those links, let me know and I'll come and put them in there. Yeah, my cat moves. All right, Isaac, Alexis. She's been really kind of annoying today, bothering me. All right, Anna M. and Seth and Jalen. All right, anyone else want to go to the breakout room and test your skills on Half-Life? All right, Julia, and if you find that you don't know in there how to do these, you're welcome to just come on back in here by hitting the X in the quiet zone title there. All right. And if you're watching the recording, I will put those in the chat in just a minute. So I've got another one to do with polonium. And let's see, I'm gonna make another whiteboard at the bottom. Okay, move this down. I couldn't find a picture of polonium because you can't have a chunk of it. It's just not something that they have in existence. All right, so I'm gonna give you guys a second and see if you can put some stuff on the board here. And I'm gonna answer, I got a private chat, so I'm gonna answer. I am not seeing a lot of work here on the board. So let me walk you through this. Can you all give me a red X so I know you're here? and ready to work? Oh, y'all are awesome. Okay, just making sure some of you guys are here with me. The half-lives, and let me turn my thing back on. Leilani, can you not write on the board? Or you just don't know how to do the problem? Okay, so we're still having issues with some of you guys can't write on the board. Did you pick a tool like the pencil tool or the highlighter tool from the list? Because if you're just on the pointer, then you won't be able to draw. Oh, okay, or it'll freeze up. Okay, yes, I've had issues with that as well with someone else and the emojis. Yeah, let me write that down because I can turn that in today. Okay. All right, so we're gonna start, we always start with 0 half-lives and 0 time. And, oh, I'm in the way. Did my video move to the right side of your screen? Okay, I'm gonna just turn my video off because it's blocking out the problem. All right, so for the number of half-lives, we just count up 1, 2, 3. And it says we have a total of 125 grams of polonium. Is that the time or the mass? So tell me in the chat if that 125 grams, is that the time or the mass? All right, thanks, Miranda. Do you guys agree with her or disagree about grams being mass? Okay, so you think that's the time, Nigel? Oh, okay, you agreeing with her that that's the mass. Yep, mass is measured in grams. So it says a total of 125 grams remain from a sample that once contained 1,000 grams. So which one of those do you think is initial that we'll put in this top box? Which one's the one that we started with? All right, so Amanda's going with 125. Anna B, Miranda, Nigel, what do you all think? Juliet, Jacob, Joseph, Jordan? Did we start with 1,000 or did we start with the 125? Okay, let me put my camera back on and I'll show you this again. Remember with half-life, we start with our sample, right? And then after one half-life, it gets smaller, right? Half of it turned into something else. And after another half-life, it gets smaller, right? To turn into something else. And it keeps getting smaller, right? So our biggest number is actually going to be what we started with. So the 1,000 is going to go at the top because we always start with the biggest sample, right? The whole thing. And then, so we started with 1,000. And then after one half-life, how much was left? What's half of 1,000? I should be holding this one. What's half of 1,000? So we're going to divide by 2. Yeah, it's 500. And then we're going to divide by 2 again. What's half of 500? So, yep, 250. And then what's half of 250? 125. And that is our target amount, right? That's not our answer, but that was our target amount in the problem. Let me turn this off so we can see the rest of the question. So it says, for how long did the sample decay? So we want to know our time, and we're looking for our time that it took to get to the 125. So what's our half-life? What was the half-life of polonium-210? Oh, I can't do that because it covers it up. There it is. It's 5 days. All right, so after 1 half-life, 5 days have gone by. After 2 half-lives, how much time has gone by? So 1 is 5, 2 of them would be 10, and after 3 of them, it would be 15. All right, so that is our answer there, the 15 days. And I think I have this with some arrows. No, I just got it filled in on there. So what questions do you guys have? And is anyone feeling ready for the breakout room and some practice? All right, Cameron, I'll put you in there. And again, the links should be in the chat. If they aren't, please come back and let me know. All right, Anna B. You can always give me a green check to head on in there as well. All right, Miranda, excellent. Anyone else ready to practice? I've got another one here. All right, so this one is about lead. How many half-lives? Ooh, this one's asking for the number of half-lives for an 800 gram sample to be reduced to 100 grams. It, it is, Jordan. You know, science has a lot of math in it because we like to quantify everything when we're scientists. So, but we're not going to do anything beyond some simple algebra 1 in this course. All right, so make another board down there. Move this down. All right, turn my camera off. Okay, so we've got some information here. I'm gonna use my highlighter tool and pick a color that'll show up on red. Okay, so I've got 800 grams of lead-210. All right, sorry, they're mowing outside, so I just closed my window. And we want it to get reduced from 800 down to 100. So what column are these grams going to go into? Olivia, Nigel, what column do you think the grams are going to go into? Leilani, Juliet, Jacob, what do you think? All right, we're going to put them in the mass. Which one's going to go at the top? Which one are we going to put for our initial mass? Exactly, Amanda, 800. All right, and then what do we do to the mass as we go down the column? Yeah, it's going to go down. We're going to divide by 2. Perfect. Good collaboration. Oop, so half of 800 is 400. What's going to go in the next box? 200, and then below that, what goes in the next one? There we go, 100. Ooh, 100. That sounds like the problem, right? All right, so that's our key amount, and it asks for how many years did it take for this to occur. So our unknown is going to be this box right here. So we have to figure that out. So how much time are we dealing with in this problem? What's the half-life of the lead? 22 days. And what do we always start with in the time column? We don't start with the 22 days. What do we always start with? Yeah, we start with 0 because no time has gone by at the very beginning. And so our 22 will go in the second one. So what goes in the column below that? 44. And in the one we're looking for? Wait a sec, we're not doubling these. I know it's a little bit different. So after one half-life, it's 22 years. And then we have to add 22 years. So our second half-life is 44. And then we're going to add 22 years. So it's going to be 66. You have different things in different columns. No problem. You know, Alexis, that's a super common mistake that students make. And so that was really good that you made that mistake, because then everyone else can see that and know that that's not the right thing to do, because they might make that mistake too. And that just puts it in the front of your mind. So very nice job, very nice job. And so, yep, there is the solution. Oh, there was a second part there I forgot about. There was a first part that I forgot about. How many half-lives are required? I skipped that one. That was the 3. Sorry about that. I didn't label them as A or B, so I missed part A. I believe that is the last one I have, which means that we need to all practice for a few minutes. We've got about 5 minutes before I want to take a look at today's lesson. So let me just find these links for you. And I will put them in the chat. Okay, there's the link to the quizzes. And here's the link to the Soft Schools, the 5-question quiz. And that was slide number, let me see if this works, if I can put this in. There we go. That was the link to the 5-question check your answer at the end quiz that you can go at whatever pace you want. So I'm going to put a timer on for 5 minutes, and then we're going to come back and take a look at today's lesson, which is changing, or which are the states of matter. What did you like or not like about the half-life practice? Any questions that came up? Oh, good. Oh, good. Couple smiley faces. All right, I do want to go back to yesterday's stuff, which would be Tuesday. Today is Thursday. And just check your understanding, make sure we didn't miss anything from our discussion on physical properties, which most of you guys had probably seen the basics of this previously. So which best describes matter? Excellent, excellent. I would love to have a little more participation. And if you think back to Tuesday, matter had mass and it took up space. It took up space. So smiley face was the correct answer. The other common answer I get is this one. But remember, density is mass divided by volume. And so you've got to have that mass in there separately, not as part of density. So that's why that one was the smiley face and not the turtle. And our second one here, ooh, let me clear. Which best describes a physical change? And this one gives you a good idea of what the questions are going to be like on the interim, where technically all the answers are correct, but there's one answer that is the best answer. Oh, actually, you know what? There is only one correct answer on this one. I'm sorry, I was not reading them very well. So, which is another thing you really want to watch for on the test, is reading the question well. So Smiley says it loses its identity. That's a chemical change, right? Where it loses its identity and turns into something else. And on OK, it says the mass is affected. But we know in a physical change, the mass stays the same, which is there in the loudspeaker. The mass and the identity do not change. So that one is loudspeaker. All right, must be getting close to the end of the week. So I was skipping over some things there, and I did this yesterday. All right, so today's lesson is on the states of matter. And so I'm going to give you just a few minutes to look through the states of matter lesson. And I think maybe we can recap probably in 5 minutes. I would like to point out that you could focus on this one, on that assignment check for understanding part, right? And go through that and see if you understand. And then if you're really struggling with it, you could go back to the instruction on this one. But if you're feeling really good about solids, liquids, gases, and plasma, that'll work for you. I actually have a little video that you can watch related to the plasma. So when you're ready to go to the breakout room, you can give me a green check. If you don't want to watch the video, you can head out right away.
The sun isn't the answer.
Oh. Oh. All right, so that's They Might Be Giants is the band name that does those. They've got a whole CD of science songs, a DVD. They're a lot of fun. So we'll see those occasionally throughout the year. Oh no, refresh, refresh, refresh. So I'll give you, well, we get out at 10:50. I was thinking it was 45. I'll give you 5 minutes to take a look at that lesson. Remember to start off at the end and give that check your understanding a look at first, and give me a green check when you want the breakout room. Point, because this I can save and the PowerPoint I cannot save. So yes or no, are solids, do they have a definite shape? Yes, they do. Do they have a definite volume? Yes, solids have a definite volume. And how about liquids? Do they have a definite shape? No definite shape. How about a definite volume? Do liquids have a definite volume? If you have a glass of milk and you pour it into a different container, does it have the same volume? Yes, it does. Yes, it does. Because if you have a 2-liter bottle of soda and you pour it into another container, it will still be 2 liters of soda. Even if you pour it out on the floor, it'll still be 2 liters. All right, so volume is our liters or our milliliters. All right, and Seth is jumping on to gases. Do they have a definite shape? No. Do they have a definite volume? No. And did you guys just do the, how did that quiz at the end, the check your knowledge go? Yeah, gas is in the air. Were you able to finish the check your knowledge part of the lesson? Oh, okay. All right. Well, make sure that you believe in yourself because I know you guys can do this. And tomorrow we will Kahoot review and take our quiz. No lessons tomorrow because tomorrow is Friday. Thanks for coming in, guys. Have a great day today, and I will see you tomorrow.